Okay, let me give you another example of different isotopes to make sure that that's clear. Let's take an example where I have 2 protons and 2 neutrons. This is a very important isotope for physics. And if I look up in the periodic table, well, first of all I can say the number of protons is 2, so that means Z, which is the atomic number, is 2. And A, total number of nucleons, is 1, 2, 3, 4. Okay, so if I look up in the periodic table, I find a box which has the number 2 at the top, and in that box is the abbreviation He. It's also short for helium. It's a gas which you use to fill up helium balloons that float up into the air. Okay. Now, in order to denote this particular isotope of helium, I would write helium-4 because it's got 4 particles in the nucleus. Another type of helium that can be found in nature has 2 protons and 1 neutron in the nucleus. 2 protons and 1 neutron here gives me Z equals 2, A equals 4, and it's still helium because the atomic number is the same, still 2, but, I'm sorry, I made a mistake. A equals 3. So 1, 2, 3 particles there, and that means that when we write down the chemical name, we get 3 helium. Alright, let's do one more example and we'll go the other way this time. Let's suppose that I'm reading an article and they say that radioactive dating, carbon dating, is sometimes done with an isotope which is called carbon-14. It's always written in textbooks like this. Well, let's see if we can make a carbon-14 atom, carbon-14 nucleus. What would that look like if we took a magnifying glass, a real powerful microscope, and looked at the carbon-14 nucleus? Well, carbon we can find in the periodic table with the atomic number 6. Z equals 6 for carbon. The total number of particles is 14, so that's A equals 14. Well, let's start writing it. First of all, we know that there are 6, Z equals 6, so that means there must be 6 protons. 1, 2, 3, 4, 5, 6. How many neutrons do I put in here? Well, let's see. The total number of particles has got to be 14. So one way I could do it is just say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. How many neutrons have I got now? 1, 2, 3, 4, 5, 6, 7, 8. Right? 6 plus 8 is 14. So this would be a carbon-14 nucleus. More common in nature is carbon-12. Carbon-12 would have Z equal to 6, A would be equal to 14, and so N would be, A would be equal to 12. That one, 12. Z equals 6, A equals 12, and so then N would be equal to 12 minus 6, which is 6. And our carbon-12 nucleus would look like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay.